Okay, so now we're going to go through multiple regression. Now, what is multiple regression? Okay, according to Palant, multiple regression is used to explore the relationship between one continuous dependent variable and two or more independent variables. And those independent variables are usually also continuous. Okay, so now in the case of multiple regression, we'll have one dependent continuous variable or one dependent variable that is continuous, that is a continuous variable, and then we will have two independent variables, and most of the time both of those independent variables are continuous variables as well. And I must just say it's not limited to two independent variables, it can be two or more. Okay, so I beg your pardon. Some of the main types of research questions that can be addressed by multiple regression include the following. Firstly, a question about how well a set of independent variables is able to predict a particular dependent variable. So now, out of our set of independent variables, we want to find out how well can this set of independent variables predict our dependent variable. The second type of research question that can be addressed concerns which independent variable out of our set of independent variables is the best predictor of the dependent variable. Okay, and then our third type of research question that can be addressed by multiple regression concerns whether a particular predictor slash independent variable, because remember predictor and predictor variable is a synonym for independent variable, it's the same thing. So like I was saying, the third type of research question that can be addressed by multiple regression concerns whether a particular predictor or independent variable is still able to predict the dependent variable when the effects of another variable are controlled. So therefore we want to see, is this independent variable, is it a constant predictor regardless of the condition of the other independent variable or variables? Yeah, because over here they didn't say necessarily independent variable, but yeah, so like it says there, whether a particular predictor or independent variable is still able to predict the dependent variable when the effects of another variable is controlled for. Okay, so then we get the major types of multiple regression. So now personally with myself, when I read the articles, yeah, there are a few cases where a person, for example, one researcher said that they used hierarchical multiple regression, and then I was like, what is that? So therefore, I suggest that, we should go through all of this, but it's only three, don't worry. But I believe it will definitely help us to better understand the articles when we read them if we know the types of multiple regression that exist, and also to grasp the concepts of multiple regression. So now we get standard multiple regression, we get hierarchical multiple regression, and we get stepwise multiple regression. So now standard multiple regression, they say here, in a case of standard multiple regression, the variables that the researcher classifies as independent variables will be entered into the equation simultaneously. So in such a case, the researcher classifies which variables count as independent variables. Okay? So then each independent variable will be evaluated in terms of its predictive power over and above the predictive power that is offered by all of the other independent variables. So now I stated here via statistical significance, but obviously, well, I can't say obviously because it's not very obvious, but an independent variable will only have predictive power if it has at least statistical significance. But now, when we evaluate the predictive power over and above the predictive power that is offered by other independent variables, I believe that we will use the beta value. That should be standardized standardized beta value. Okay, so we'll get to that now. So now they say that standard multiple regression, they say that this approach will also indicate the amount of unique variance that the dependent variable, or let me rephrase that, it can also be used to indicate the degree of unique variance that each independent variable has towards the dependent variable. Now, if a independent variable has unique variance, it means that that independent variable does individually or solely contribute towards the variance of the dependent variable. So in other words, the variance, or it's the independent variable, if it has a unique effect, its influence towards the dependent variable is individual and it's not influenced by other variables. Okay. So now let me just quickly look at something. Okay. Okay, well, in terms of predictive power, maybe if one independent variable has more of a statistical significance, for example, a p-value of 0.01, remember that if the p-value is 0.01, then it's a 99% confidence that we have in that variable, whereas if it's 0.05, we have 95% confidence in that variable. So I'll say again 0.01, if a p-value is 0.01, okay, 99% confidence, 0.05, 95% confidence. Okay, so like I say, we'll go through this again one last time. Okay, so standard multiple regression, in such a case the variables are classified by the researcher as to whether they are independent, and they're entered into the equation simultaneously. Each independent variable is evaluated in terms of its predictive power over and above the predictive power that is offered by the other independent variables. Okay, and then we say this approach will also indicate the amount of unique variance that an independent variable has towards the dependent variable, and that'll be indicated by the standardized beta value. Okay, so now moving on to hierarchical multiple regression. Let's say that in the case of hierarchical multiple regression, the independent variables will be entered into the equation in an order that is specified by the researcher, and that order will be motivated by theoretical grounds. So I have an example over here. No, it's not this example. It is, okay, this one. So as this text states that the independent variables will be entered into the equation in an order that is specified by the researcher. As we can see over here, in this case, in step 1, the control variables were entered alone. And then we saw there wasn't any significance in either of the variables, the control variables towards our dependent variable, which in this case is self-rated performance. Okay, so therefore, the whole point, hierarchical multiple regression, the independent variables are entered in a stepwise manner, and this is applicable over here because as we can see, step 1, only the control variables were entered. But then in step 2, the predictors were also entered. So like I say, there's a stepwise order over here. Okay. So for interest's sake, in this case, when, let's say the researcher wanted to see if the control variables alone, gender, age, satisfaction, and effective commitment, if they alone had an effect towards self-rated performance. So over here we can see that none of these values are marked to have a statistical significance. Because you can see over here, p-values, there are no stars attached to either of these numbers. Okay, so in any case, we can then say that the control variables do not have a significant influence towards self-rated performance. But however, then when the predictor variables, job embeddedness and work engagement were entered, we can see that an asterisk, or a static key if you want, you'd call it in Afrikaans, it was not attached to, or no, it was, we can see an asterisk was attached to the value, so therefore they have statistical significance. So over here we can see that the control variables alone do not have an influence towards self-rated performance. However, job embeddedness and work engagement do have a significant influence towards self-rated performance. And over here, these values, when they were entered into the equation, these values did not really change. So, yeah, like the whole point over here, we're using this as an example of hierarchical multiple regression. Okay. And then we get stepwise multiple regression. So now they say when using stepwise multiple regression, the researcher will provide a list of independent variables and will then allow the program to select which variables it will enter and which order they go into the equation. So in stepwise multiple regression, the researcher once again provides a list of what they believe to be the independent variables, and then they allow the program to select which variables, or the variables that will be entered into the equation, as well as the order by which they'll be entered into the equation. Okay, so now interpreting a linear regression table. So now I must just say I did not get these steps or this particular order out of a book or anything. So therefore these are based on my own logical summary, and I trust that they are correct and all of that. So now the first step we want to look at is the R square or adjusted R square value. So now what the R square or adjusted R square value will do is it will basically indicate the amount, or the proportion, should I say, rather the proportion, in other words, we can say the percentage of variance in the dependent variable that is explained by the model. So now the model refers to the combination of independent variables. So as it was typed over here, this value will indicate the amount of variance in the dependent variable or variables that can be explained by the model. So now, in the case of a large population sample, and I'm not sure about the parameters there of what distinguishes a large from a small population sample, but we'll get to that now. But I say in the case of a large population sample, the R square value will be used. So in other words, in the case of a small population sample, the adjusted R square value will be used instead. So big population sample, we use the R square value. Small population sample, we use the adjusted R square value. So now, if the R square and adjusted R square values are both placed in the table, use the value that holds statistical significance. So let me quickly look for an example over here. I believe it was this table. I will over here, the R square value. Yeah, I see over here both of them are the same, and I'm not sure, I'm not 100% about if that is an adjusted R square value. I still want to ask Rizal. But like I say, over here they're the same. There the R square value is 0.31. So now if we times 0.31 by 100, what will that give us? That will give us 31%. So therefore this model that we've got over here, these independent variables, job demands and job resources, can explain 31% of the variance in our dependent variable, which is work engagement. So therefore, job demands and job resources can explain 31% of the variance in work engagement. Okay. So then, yeah, like I say, look at the sub-comments of the table to see if the author used another means to indicate the R square or adjusted R square value to indicate which of them has significance. Like I said here, usually an asterisk is used. Okay, so now I made a note. Remember, the R square or adjusted R square value times 100 will indicate the amount, or should I rather say proportion, the proportion of variance in the dependent variable that is explained by the model. So now, like I said earlier, the model would refer to the independent variables that were involved in the study and those that hold significance. So now secondly, so we said, okay, we're interpreting a linear regression table. Firstly, we look at the R-square value to see the proportion of variance in the dependent variable that is explained by the model. So then we go and we identify and distinguish the dependent variables, the dependent variable from the independent variables. Okay, excuse me. Okay, so let's look at this example. Okay, results of regression analysis in predicting work engagement. So if we predict something, it is the dependent variable. So we're predicting it by job demands and job resources. So therefore, job demands and job resources are our independent variables. Okay. So therefore, all of the values that are indicated here refer to the influence towards work engagement. So then the next step that I've concluded we should follow refers to locating the beta values and only considering those that are statistically significant. Okay, so the other comment I made, okay, locate the column that consists of the beta values of each independent variable. Okay, so if we look here at the bottom, this says standardized regression coefficient, and I believe that is the beta value, and it's denoted by this symbol over here. I'm just quickly double checking that my presumption is correct. Okay, I believe yes, this denotes the standardized beta value. So over here, okay, you see these are the beta values. Okay, both of them, okay, both of them have statistical significance because we look at the p-value. Now, a p-value must be equal to or less than 0.05. So these are less than 0.05, and remember, a p-value of 0.05, but that is higher than 0.01, that'll indicate that we can have 95% confidence in that suggestion or the answers that are based on the statistic of that variable, and then a variable that has a p-value of 0.01 or less, we have 99% confidence. Okay, so now getting back to the steps. Okay, locate the beta values and only consider those that are statistically significant. So like we said here, both of them are statistically significant. Okay, and I made a note here. If the variables that have beta values will be the independent variables. So therefore, if we're battling to find independent variables in a linear regression table, look for those that have beta values, okay? And like we've said here, beta values are also referred to as standardized regression coefficients. I believe that's the conclusion I reached based on this table. That's a note I made. Okay, so now we say only consider and further analyze the beta values that are statistically significant. Okay, the statistical significance of a value, including the beta value, will often be indicated by means of an asterisk. But in this case, the p-values are just stated there. Okay. So then we say, however, some authors may use other means to indicate the statistical significance or whether a variable has statistical significance. So like I say, always read the sub-comments. So then we go on and we say, interpret the beta values. So let's look at the comments over here firstly, okay? The independent variable with the highest beta value, should I rather say, will have the greatest unique effect towards the variance of the dependent variable. So let me read that again. The independent variable with the highest beta value will have the greatest unique effect towards the variance of the independent variable. Okay, so now if it is said that an independent variable has a unique effect towards a dependent variable, we say that that will suggest that the independent variable does solely influence the variance of the independent variable to an extent. So therefore, that independent variable that has a beta value, it does have an individual influence towards the dependent variable. So in other words, its influence does not depend on the movement of the other independent variables. But now in terms of beta values, so over here we're looking at the beta values. Job resources has the highest unique effect towards work engagement. And that makes sense because your job resources and work engagement, as we know, are very, very close and all of that. So if we look at the beta value of job resources, it is 0.538, whereas job demands is 0.93. So like we say, job resources has the highest unique effect towards work engagement. So therefore, take job demands away, job resources will still have quite a big effect towards work engagement. Okay, so should we go to the next table and then look at that one as well while we follow the steps? Okay. Okay, so in this case, they say a regression analysis predicting the dedication of subscale of work engagement. So therefore, dedication is a subscale of work engagement. But we say that we're going to look at the extent to which dedication as the dependent variable can be predicted by job demands and job resources. So therefore, if these are predicting dedication, dedication is the dependent variable and job demands and job resources are the independent variables. Okay? So now, what is the... Okay, let me just quickly see. I see there's an A over there. Okay, so I'm just trying to think about that A above the R over there. That's referring to the adjusted R square, but now I don't see a square next to it, so all the square symbol, so yeah, then I presume that is not the adjusted R square. Okay, but in any case, so now interpreting a linear regression table, we said the first step we want to look at the R square value or the adjusted R square value to see the proportion of variance in a dependent variable that can be explained by the model. So over here we want to see the proportion of variance in dedication that can be explained by job demands and job resources. So we look at the R square value here. We times that by 100. We times 0.345 times 100. That will give us 34.5%. So therefore, job demands and job resources can explain 34% of the variance in dedication. Okay, so what is the next step then? We want to identify and distinguish the dependent from the independent variables, and we have done so. So, okay, what is the dependent variable? Dedication, okay? And then the independent variables are job demands and job resources, okay? So, therefore, we have done that. Then we go and we look at the beta values, and we only consider those that are statistically significant. And I must just say, in cases where this constant value, we don't look at the constant value. So, don't worry about that. So, in any case, we want to see, okay, out of our dependent variables, there are beta values. Okay, are both of them statistically significant? If they are not statistically significant, we'd have reason to exclude them from the analysis. But as you can see, that is not the case over here because both of our independent variables are statistically significant. So then what we do is we go on to look at the beta values. Where are the beta values? Okay, these are our beta values. Okay, it's also referred to as the standardized regression coefficient. So now looking at our beta values, which variable, independent variable, has the highest beta value? Okay, job resources. Okay, nice one. Okay, so therefore, in terms of the unique effect, if we want to know about which independent variable, job demands or job resources, has the highest unique effect towards dedication, we can see that job resources, once again, has the highest unique effect. But in this case, job resources has the highest effect towards dedication. Okay, so therefore, between job demands and job resources, the dedication of an employee will be more influenced by their job resources. Okay. Okay. So now we go to the next table. Okay. Now over here, read this. What is our dependent variable? What are we predicting? As you can see, we are predicting work-based identity. So that's our independent variable. And we're predicting it by job demands and job resources. So therefore, these are our deep independent variables. I'm just quickly reading this and making sure that I'm correct. The results of regression analysis and predicting work-based identity by job demands and job resources. Work engagement by job demands and job resources. I wonder if the author made a typing error over here, because yeah, I think that, yeah, like I said, I think they made a typing error. But yeah, I think they missed a word. But okay, Mark, I believe over here, work-based identity is our dependent variable. Work-based identity is our dependent variable, and job demands and job resources are our independent variables. So therefore, okay, the first step, what do we want to look at? Okay, we want to know how much of the variance of our dependent variable can be explained by this model. So of course, the more variance, the better. So as we've seen, we look at the R square or adjusted R square value. Over here, R square equals 0.389. So therefore, this model, job demands and job resources, can explain 38.9% of the variance in work-based identity. Okay, and then we said we want to look at, well, we said identify and distinguish the dependent from the independent variables, but it looks like that is the first step that we follow. So yeah, I'll just make a note of that, edit this document if you want to. But yeah, so then after we've found out about the amount of variance or the proportion of variance that can be explained by a model, we go and we want to see the independent variables that have the highest unique effect towards our dependent variable. And like we've said, unique effect, okay, in terms of that, the variable that has the independent variable that has the highest unique effect towards excuse me, I'm trying to think, I lost my train of thought for a second. Okay, the independent variable that has the highest unique effect towards the dependent variable basically holds the most independence towards explaining the outcome or the dependent variable. Okay, so just look at the comments over here about what is meant by a unique variable. So now we want to see out of job demands and job resources as our independent variables. Okay, firstly, we look at the statistical significance. As we can see, in the cases of both of our independent variables, they have statistical significance. Okay, now which of the two have the highest beta value? Okay, 0.65 is greater than 0.95, and that is job resources. So therefore, job resources have the highest beta value. So therefore, job resources are the highest unique, they have the highest unique effect towards work-based identity. Okay, so for example, we'll see over here, let's look at how they discuss the suggestions of the tables, okay? Okay, so let's first look at the outcome variables, the dependent variables. Okay, so we said job demands yielded a higher beta weight in work-based identity. Okay, where's work-based identity? Let me start from the beginning. Job demands yielded a higher beta weight in work-based identity than in dedication alone or work engagement combined. Okay, so job demand, work-based identity over here, 0.95. Over here it was 0.67.